For the angle of minimum deviation of a prism to be equal to its refracting angle, the prism must be made of a material whose refractive index lies within which of the following intervals. In the first diagram here, the angle at the top is called the refracting angle because the two surfaces through which refraction is taking place are the same surfaces that make up this angle. This angle is the angle of incidence and this angle is the angle of emergence because they are the angles that the incident and the emergent rays make with the normal to the surface. In the case of minimum deviation, these two angles are equal. This angle is the angle of first refraction and this angle is the angle of second incidence, and both of them are also equal in the case of minimum deviation. Let us now look at this white quadrilateral that I am drawing over here. The sum of angles in a quadrilateral must be equal to 360 degrees. In this quadrilateral we have two angles as 90 degrees because the purple dotted lines are perpendicular to the surface. One angle is A, so the last angle must be equal to 180 degrees minus A. Now let us look at this yellow triangle that is basically the bottom portion of this quadrilateral that we have just taken. We have R plus 180 degrees minus A, which is the sum of angles in the triangle, is equal to 180 degrees because the sum of angles of any triangle is equal to 180 degrees, and therefore we have 2R is equal to A, or R is equal to A by 2. Now let us move to this second diagram in which we have these green dotted lines as the extension of the incident and emergent rays into the prism. So this angle would be I and this angle is R. So the difference of those two angles is I minus R. And due to symmetry in the case of minimum deviation, this angle is also the same, I minus R. Now this angle between the green dotted lines is called delta, or the angle of deviation, and it is minimum in this case which you have taken, which is the minimum deviation case. The property of a triangle is that an external angle such as delta is equal to the sum of the two internal opposite angles. So delta is equal to 2 times I minus R, and we are given that angle of minimum deviation is equal to the refracting angle. Therefore we have A is equal to 2I minus 2R is the same as A, or 2A is equal to 2I, or A is equal to I. And we already know that 2R is A, so we have A is equal to I is equal to 2R. Now from Snell's law we have the sine of the angle of incidence is equal to the refractive index multiplied by the sine of angle of refraction. I can write R as I by 2. So on this right hand side we have, I can also write sine I as sine of twice of I by 2, or 2 sine I by 2 cos I by 2 is equal to n times sine R is I by 2, so we have n sine I by 2. Sine I by 2 cancels out, so we have n is equal to 2 cos I by 2. Now the angle of incidence can only vary between 0 and 90 degrees, or 0 and pi by 2 radians. Therefore, cos I by 2 can only vary between, at I is equal to pi by 2, we have cos I by 2 or cos of pi by 4 to be equal to 1 by root 2. And when I is 0, cos I by 2 is 1. So 2 cos I by 2 lies between the square root of 2 and 2. Therefore, option B is the answer.